Hello and welcome to today's video, and today we are just going to go through what I've done with the TTF1 module. So as you can see here, these are the new capacitors. They are 450 volts, 4.7 microfarads, replacing these ones which were 350 volt, 4.7 microfarads. You can see how they are a lot smaller, but actually a bigger voltage, or a larger voltage, which is interesting. Seems to be the way a lot of these things have gone, is they do seem to have got smaller. The original capacitor here I've retained. I did purchase another one, a 450 volt one here, of the same of the same farad rating, but as you can see, it's actually a lot taller than this one. So because this one is actually measuring perfectly, I've put it back into operation. However, we don't have any voltage getting to this, which is interesting. So what I'm probably going to have to do is remove this little board here and just check under there for the fuses that may have blown. I've checked the continuity across this fuse here, and it seems to be absolutely fine. However, I can't discount that there may be something wrong with this little distribution board, or smoothing board rather. So that will be something else that I will need to remove and check out a little bit further. So that's where we are with that one. As I say, the next thing to do would be to remove this board. In fact, let's do that now, so bear with me a second. So with that one out of the way, you can see that we do have this little fuse here, and let's see what the continuity on that fuse is like. If it's open circuit, then we have a problem. Now I'm actually going to try and zoom into it to see if we can see the inside of it. And it's very difficult to see the inside. Light conditions in here are not the best at the moment, so it is going to be a little bit hard to obviously see inside there. I'm going to get it out and check the continuity and report back. And it's measuring absolutely fine. Now I'm interested to see what's underneath this board, to see, because you've got the power switch here. That power switch seems to go into here, but also comes from here. So I think that would be the main fuse in there. Then it would go into the power supply here. This board is being fed by some cables which go onto the board underneath. And I'm wondering if there's another fuse somewhere. So I'm just going to pause this, get this board out of the way and have a quick look. So I've got the power supply into a position where I can actually check some of the points on that supply, so bear with me. There we go, so we have power going through at the moment. There's our multimeter, which I'll rest there. And you can't see the multimeter, so if I bring this back a little bit and pan up, there we go. Excuse the mess, there's a lot going on in the office this morning. There we go. So here's our AC in. And if this is to be believed, oh, it's under there. Hang on a minute. Let's power it off and expose. Don't worry, it's powered off. Bear with me, I'll unplug it and expose the connector. There we go, that's exposed. So I've powered it back on. It'll be alternating current coming into this side. These are our terminals here. Number 3 is negative, number 1 is live. So let's just go on to those, and we have No volts coming in. That's interesting. So that is, yeah, that is definitely dead. It's definitely plugged in, and that is definitely very much dead, which is interesting. So that would lead me to think that there's a problem this end. So there's nothing getting to this board. That's our main point into the board. There is nothing getting to this board at all. So we can also check to see what our massive capacitor's doing, which is here. So nothing on that capacitor. You would expect to see that charging to at least 400 volts. Absolutely nothing on that. It's definitely not direct current. I'll even check here. It's definitely not direct current. It's alternating at this point when it comes in. Absolutely nothing there. So again, alternating because it is going to be AC in, it tells you. Absolutely nothing. So I either have a problem with the switch, or we have a problem at this end here. So there was definitely some issues with this board. We did check. We noticed that the capacitors that we replaced were at fault. They were, as you can see, like that. And if I stick them onto my ESR tester, which I'll do now, as you can see, they have an ESR of 1.5 volts and 5,881 nanofarads. They should be 4.7 microfarads. I've got a feeling they might be open circuit, which is probably why they're giving us unusual readings. I've just turned it around. Yeah, they're probably open circuit, and they do look a little bit puffy at the top, so I think they are gone, unfortunately. So next things for this, I'm going to have to check this end. Definitely. There is definitely something not quite right there. Actually, what I can do, I can power it off. I can take this, which, let's just have a quick look in there, see where, take this out. That's going to be from our switch. So the mains plug comes in. It actually does go onto this board, so you've got a point down there and a point at the top. Now, I seem to remember measuring that before and I had voltage. Let's try it again. So I've now isolated this. Now we should have voltage across the mains. So let's borrow this again. We're looking at alternating current, and we have, excuse the creak in the background, get this isolated as well, so move that firmly out the way. Over there you go. So we got live, and over here neutral. So if we hang on, go on to there. Oh, yeah, we've got 240 coming in, so that's our problem there, and that is where we're going to have to focus our attention. Right, so that is actually it for today. I just wanted to check a little bit further, do a bit more troubleshooting, which I've done. I'm probably going to remove this board and test the various components on it, because there may be a component on there that could be badly soldered, it could be open circuit, it could even be the fuse that I've put in there may also be broken. However, because that part of the machine is always hot, always touch this particular section, or never touch that particular section with the machine plugged in. Always make sure that it is unplugged. What I will do is you can get the actual switch mode module out of the way, because this may actually be absolutely fine. There may be no problems with this now whatsoever, now that I've replaced those capacitors. What it does allow you to do is it gives you access to get into here, and this will pull out like so, and that will give you access to this board here. So what I'm going to do is remove this board. So just so you can check, there's our plug. We are completely isolated from the mains. Not having the switch mode module in place actually makes this a lot easier to determine, sorry, not determine, to actually get to. So if I, here's one, and here's the other. It's a little bit tricky to get out, but it does work eventually. There we go. There we go. So that's that one. Now to get to it fully, I need to, I think, undo this little black panel at the back, which is sort of like a cable management arrangement. I can move the soldering iron out of the way, so I'm not going to move that immediately. So there's a couple of screws holding this in. There's that one, and this one. There we go. Ow. And hopefully that will allow me to do this, which means, move that out of the way, I can now feed that through and access this board here. So let's have a look at it. You got a couple of resistors, there's the fuse, you got a link, got a resistor, you got what looks like a mains smoothing capacitor, which will be this thing I'm guessing, and you got these. I guess those are, they're resistors, but I think they're fusible resistors. And then you've got this here, which is a little transformer. So what I'm going to do first off is check continuity. The first area I will check for continuity is our fuse. I've already checked it, but it's not going to be detrimental if I check it whilst in situ in the unit itself. So let's grab resistance, No resistance across the fuse. Let's check this filter capacitor. So filter capacitor. Oh yes, I see. There is a... They look like they're part and parcel of the same thing. The capacitor and the resistor are the same. That's measuring infinite at the moment, and there is resistance across there, which is expected, but what's interesting is that, if I'm reading this correctly, the capacitor here has infinite resistance across it. Could this be at fault? The thing that sort of confuses matters is it's going in effectively to the same terminal point as the fuse, and it is a 300 volt affair. Let's check these resistors here. Are they open circuit? No, they don't seem to be. No, there's probably resistance on them, but they should be 1.8 kiloohms, I think. I'm currently measuring 2 megaohms, so if I go down to 2 kiloohms, I might be able to measure the resistance across them properly. Yeah, that's about 1 kiloohm, I think. Is it? Possibly? I don't know, hopefully. It could be... Yeah, they're measuring the same, so I'll go down to 200. That's where it may actually overread. So let's do that again. Yeah, 2.0, so... Let's see if I've got a suitable tester I could use. Ideally you want to take them out of circuit to measure them, but I'm just interested at the moment to see if I get anything at all. So as a resistor, it's measuring up at 2.14 ohms. Okay, could it be that? We need to take those out of circuit really to test them properly. Because I reckon if I put the connector thing directly onto the leg, it'll measure completely different. We need to measure those out of circuit ideally. Let's check here. .24 ohms. 1.8 ohms K. 1.8 ohms K. It may not actually be kiloohms. It could just be. So they are a little high. Possibly, those are possibly a little high if it is just ohms. Should be 1.8, they're 2.4, that's a possibility. There are scorch marks on this, capacitor, so there is every possibility that it isn't happy. Let's test it in circuit. If I can, I need to grab hold of a leg. Just squeeze in there, there's one. And this side should be easier to get to. There's two. ESR 0.99 ohms, 105.5 nanofarads, so there is something there. I probably can't measure anything across it with continuity because there's no charge in it. 300 volts doesn't actually give you what rating it is, but that might be okay. Those might be high. This one here, can't even tell what rating that one is, to be honest with you. But they rarely seem to go wrong there, that's the thing. This transformer, I suppose we could try checking the continuity across it. Again, not sure if that will work, but it may give us an indication if there is a short in said transformer. So said transformer goes from here to 2 points here, so let's have a look. So let's go straight over first. That's not looking great, nor is that. Okay, there's continuity between these two, but I thought they were on the same side, so there's got to be continuity probably between the windings rather than inside across the transformer. So let's check this one. To be another winding, and that has continuity across the windings. So yeah, because you don't actually have contact with the wirings inside, it's the wirings. So there's one side, there's the other. Both sides there is continuity, so I don't think there's an issue. Fuse is fine. That I'm not so sure about. This resistor there, I'm not so. It's these two that are causing me the worry at the moment. Well, not the worry, just causing me. It is also completely possible that we have a duff power switch. That's something else that we can't rule out. Right, I'm going to put this back together so I can put it away neatly. But for the moment, that is all we're going to be doing with this machine today. I'd like to thank you for taking the time to watch. If you have any suggestions, don't forget to leave them in the comments. And I will see you soon. Thanks for watching.